All right, here's our notes for writing equations using transformations. The notes in the practice sheet look real similar, so be sure before you start working that you're on the notes page and your first problem looks like this. What our goal is to do is to take the general form equation, look at some graphs of transformations, figure out how it's changed, and based on those changes, determine the A, B, H, K, plug it in, and write an equation for the graphs that we see. And the steps that I like to do this in are that I'm checking for the origin shift first. Did the origin of the original function shift left or right? That's going to give me my H and K. The next thing I do is check for any reflection over the axes. That'll let me know if my A or B values are negative. And then the last thing I do is check for a vertical or horizontal stretch or compression. And that will determine my A value or my B value. Maybe both. So each of the rows on our sheet is the same shape, just two different examples. So these first two examples are quadratics. So my function is x squared. And the first thing I'm going to do is check how my origin shifted. So the origin for the parent function is at 0, 0. And it looks like in this case it just shifted down. So down 3 means my k value is negative 3, right? Because the k is the vertical shift. And h is for a horizontal shift, but it didn't go left or right. So it's just 0. Then I'm going to check for reflection, meaning did the original shape, which was the original shape is pointing up, now it's opening down. So that is a reflection over the x. So it reflected over x. That means my A is going to be negative. So reflect x, A is negative. And then I'm looking for a vertical or horizontal stretch or compression. And here's how I am going to do that. On the original shape, if there's no stretch or compress, starting at the origin, I should be able to do a counting pattern of over 1, up 1, and land on the graph. But here that doesn't happen. So if I go over 1, down 1, so in this case I'm going down because it's facing down. Over 1, down 1, I should have landed on the graph, but I don't. So what I want to do is look for a point on the graph that's an integer value, and meaning it's whole numbers, positive or negative. And I have one right here. So in order to get from my origin to this point, I have to go over 1 and down 2. So of my original 1, 1, the x didn't change, but the y did. The y value went from 1 to 2. So this is a vertical stretch of 2. That means my A is 2. So the original y value should have been just 1 unit. It's 2 units, so it's 2. So now I can plug all that into my general form equation. Y equals A, which we said is both negative and 2. So negative 2. Then x squared. Technically the h is a 0, so I'm not going to put anything in there. It's just squared. So you could think of it as x minus 0, parentheses squared, or just x squared. And then the k is minus 3. So I would like you to pause the video and try this one by yourself. So the answer to this one is y equals 3 parentheses x minus 3 parentheses squared plus 2. And look in your Google Classroom for the completed notes, and you can see I have notations for where all those values came from. All right, for number 3, this parent shape is square root of x, so that original shape looks like this. So you can tell, so first let's talk about the origin shift. The original origin was 0, 0. This one went to the left 2 and up 2. So up 2 and left 2. So up 2 means k equals positive 2. And left 2 means that h equals negative 2 because it went to the left 2. So then the second thing that I want to check for is a reflection. And this one did reflect because in the original shape, it's going up and to the right, and in this shape, it's going down and to the right. So it did reflect over the x-axis. So it reflected, a reflection over x means a is negative. And so now we want to check for vertical stretch or compress. So I should be able to, my counting pattern would be over 1, down 1, and I should land on the graph. But you can see that I need to go over 1 and then down 3. 1, 2, 3. That means the original y value that should have been 1 is now 3. So it's been 1 times 3. It's been multiplied by 3. So a vertical stretch 3. So that means a is 3. So now plugging that in. So again, my parent general form is this. Where my original function is square root of x. So I've got y equals a, which we said is both negative and 3, the square root of x. Now, however, the horizontal shift goes inside here. So really it's a minus from the general form and a negative 2 from the shift. But negative, negative makes a positive, positive. So it's x plus positive 2. And I'm just going to, you don't have to rewrite yours, but I'm just going to rewrite mine as just a plus 2. Right, so square root of x plus 2. And then outside the function is your vertical shift, your k of plus 2 for up. All right, so I want you to take a second, pause the video, and you try this one right here. And use this value here for your vertical stretch or compression. All right, hopefully you got y equals 2 times the square root of x minus 4 minus 3. And again, go look in your Google Classroom for the completely filled in notes, and you'll see I have a bunch of notes here that let you know how I got those values. All right, on the back, this row right here is for absolute values. So the original function is y equals absolute value of x. I'm going to check for my origin shift first. So here's my new origin, and it's down 3. That means k is negative 3. And left 3, that means h is negative 3. And I'm going to go from my origin to this point. Second, let me check for a reflection. There's no reflection, right? It's pointing up just like the original function, so a is going to be positive. So my vertical stretch, I have to go over 1 and up all the way to here. So over 1, which means x didn't change, but my y value went from 1 to 4. So a vertical stretch by 4 means a is 4. So now I can just plug in y equals positive 4, absolute value, x minus negative 3, so that's an x plus 3, and then k is minus 3. Now I'm actually going to work through 6 with you because it has this is the first one we have a horizontal stretch or compress, and I want to remind you how to put that into your formula. So we start by shifting the origin. So here's my 0, 0. I have to go right 2, so h equals 2, and then up 1, 2, 3, 4, 5. So k is equal to 5. The shape is reflected down, so my a is negative because of the reflection. And then let's use this point right here to figure out our vertical or horizontal compression. So to get from here to here, we should be counting over 1, down 1, but it doesn't work. So we need to count over 1, 2, 3, 4, and then down 1. So the y is 1, which means it was not vertically stretched or compressed, but the x value went from 1 to 4. So the x's were multiplied by 4. However, whenever you're doing something inside with the x, whether it's adding an h or adding the b in, I'm sorry, not add as in the operation, I mean filling it in, you're going to do the inverse. So the inverse of multiplying by 4 is dividing by 4, or in other words, multiplying by a fourth. So that's going to be my b value. So my function is absolute value, and I'm going to fill in my values. My a is negative, but there was no vertical stretch, so a is 1. So you can write -1. I'm just going to write a negative. And then absolute value. Our b value is 1/4, and be sure you have parentheses around the x and the horizontal shift. So x minus the horizontal shift of 2. Close your absolute value, and then k is plus 5. You need the parentheses to be 100% correct here. And then for this last function, we have a rational equation. Now, when you're looking for the origin shift here, you're really looking for where do the asymptotes intersect. That's where your 0, 0 moved to. So it went over 2, so h is 2, and down 3, so k is -3. Look for a reflection, but this is our original shape. A reflection would change these shapes to the other quadrants, but they're in the original quadrant, so there's no reflection, so A is positive. And then do your 1, 1 count. So I go over 1, up 1, I land on the graph, therefore no horizontal or vertical stretch or compress. So my original equation is 1 over x, and now I'm going to add in my changes. So 1 over x minus 2, right? So that's my horizontal change. It goes with the x in the denominator. But this -3 is the k. It goes all the way outside at the end of the equation. It's not included as part of the fraction. So pause the video and try this next one with the 1 over x. Notice this one is a reflection because the curves are in different quadrants. So take a minute and try that. All right, hopefully you had a good, you had luck with that one. The equation is y equals -1 over x minus 2, and then -3 at the end. And again, for the notations for that, where I got those values from, go look at the completed notes, the PDF, and it'll have the annotations with the information.